tell you, sir. That time you can start.
Okay. Just want to know, like these two students are there. Okay.
Yeah, like more students would be joining then. So yeah.
Okay. Hello there. Myself Shamil Rathod, and welcome to the school quiz. As you can see, there are two students out there, Rani and Vaishnavi. Right? Am I audible? Um,
Yes, sir.
Yes, sir.
okay. Hello, Rani and Vaishnavi. Let me, as you can see, like as you watch my previous video on school quiz, are you? Do you know there is my videos on the school quiz? Hello. So, Vaishnavi, are you from 8th class, right? You are from 8th class. And Aniket is from 9th as well. And which class are you from, Rani?
Sir, 8.
8th class. Okay. So, have you watched my videos on the school quiz? Anybody? I think no one, right?
Yes, sir.
Yeah, right. Vaishnavi is watching it. So it's for the class 10th, right? But you haven't watched it for the class 10, you are in 8 right now. So first of all, I just want to know, is there any doubt regarding with the your science chapters or whatever? It's from science chemistry, right? So any portion in the chemistry section of your class 8 science. So you can ask me about that. Anybody is having any kind of doubt with regarding to your class 8 chemistry or maybe for the bio
Yes,
as
sir.
well. Who's this one? Okay, ask me. I will try to solve it. Right, Adit Kumar.
Sir, please explain about isomers in carbon and its compound.
Okay, I will explain the isomers and its compounds here. Okay. So first of all, let me tell you about the carbon. Wait a minute. So, as we all know, carbon having the atomic number 6, right? And it having 4 electrons in the outermost orbital, right? So, if a compound have to form a specific, like, if carbon have to join with another carbon, they have to share the electrons. What kind of, they have to share the electrons. If they share the electrons, they will bond it like that, right? Carbon having a property of catenation, as you all know, carbon can make its bond with another carbon. There is no definite number for any specific structure, right? So isomers are generally the structure by which the carbon shows itself or the property of itself, right? So as I'm writing here, CH4, C2H5, C3H8, right? So in this compound, carbon share electrons with the 4 hydrogen atom, right? But what about that structure differs these two units, C2H5 and C3H8? Can we make different structures. Can we make the different structure? Like here, if I'm draw carbon with carbon with carbon with carbon, and here right. So as you can see here, this carbon structure is a linear chain. Is a linear chain, but not in this. Like we have 4 carbon in each of these compounds, right? But the structures are different, right? The structures are different. So if the structures are different, if the structure are different with specific number of carbon that we can see, we have drawn these 3 structures and we have only 4 carbons in, right? So if the structures are different, they will known as the structural isomerism. Isomer or isomerism defines that if a structure of a specific element differ in the form of bonding, then it will form the isomers, right? There are different kind of isomers like structural isomers, and we have different isomers like let me draw something. Let me draw something for you. Let me attach chlorine here, and there is a hydrogen. Is this a structural isomer or what? As we can see, there is a hydrogen, right? Hydrogen is here and hydrogen is here. But if we draw a mirror image, then we can see sorry. We can see that the chlorine changes its position to here, but in this structure, there is a hydrogen, right? So this is a cis trans isomerism. We see here that this is the structural isomerism and this is the cis trans isomerism. So what is the difference between them? The difference is the structure that defines that specific formula or any formula having different kind of structures. As you can see here, this is a linear chain, this is branched, and this is cyclic structure, right? We have learned these 3 structures in the class 10th lecture, that this is a linear structure, this is a branch structure, and this is a cyclic structure. But all of them contains only 4 carbons, right? So if the compound is differed by the structure, then it will known as a structural isomerism. Am I clear, or you need further explanation?
So then what is the difference between these chains, cyclic chain, all these chains? There are 3 types of chain in class 10. Then what is the main difference between them, sir?
Actually, the difference is if any compound form any kind of structure, they will get a specific chemical property or the physical property. As we can see, if we have a 4 carbon compound like this, like the 4 carbon compound is like this, and the 4 carbon compound is like that. But if we can use it in the real world, like not in the theoretical or in the practical way, these structure will show different kind of chemical properties and the different kind of reactions as well, right? We cannot define that specific structure of that specific chain in the real world, but in the theoretical way, we can draw it like that. These bond lines are not real actually. It's just the intermolecular forces. So as we can see, in electron microscope. Electron microscope, but there are various kind of machines to observe these kind of structures. And when we specify these structures, we will know that the specific property of these substances are differ from each other. So the structural isomerism shows that these structures can have different chemical properties and they have different functions in the real world. Okay. Is this clear?
Yes, sir. Sir, can you give a brief note about that Mr. Buck fluorine, sir?
Can you speak again?
सर थोड़ा सा सर मिस्टर बक फ्लोरीन सर जो बेंजीन वगैरह जो सर चेन होता है सर मिस्टर बक फ्लोरीन होता है
Okay. Actually, you are asking about the Buckminster fullerene, right?
yes sir sorry sir that
Yeah. It's Buckminster fullerene.
yes sir
There's
Mr.
a
Buck
scientist named Buckminster fullerene who gave the structure of carbon, and they give the structure of carbon on a specific way. Like as we can see that carbon having different kind of allotropes, right? Carbon having different kind of allotropes, as we can see here, like diamond, right? Diamond having the hexagonal structure. Diamond is having the hexagonal structure attached with that. It's kind of wait a minute, okay? Let me draw this, and then I will explain you. As you can see here, the diamond having a different structure compactly bounded with the hexagonal structures like this, right? If the hexagonal structures are arranged in these pattern, then we will get a surface, or we can say the reflective surface. So as we know that diamond having a reflective surface, just because of that, the diamond sparkles a lot in the light. Because of what? Just because of internal reflection. With specific property, Buckminster fullerene introduced a ball-like structure. Ball-like structure. In this, the carbon are attached with different 60 carbons, right? So the chain is mainly bound up with the ball-like structure, and this chain is completely arranged in a ball-like structure. So the Buckminster fullerene structure or the carbon C60 structure, as we can see here, if I draw like this, the ball is in the 3D pattern. I will not draw it completely, but I will explain you that specific thing. Like each carbon is attached with different number of carbons, right? As we know, carbon can bond 4 bonds with different carbons, right? So the Buckminster fullerene or Mr. Fullerene explained that the carbon having a property of catenation to form an allotrope, and the allotrope condition, as we have some examples like graphite. Second is diamond. And the third one is fullerene, right? They gave its name on himself. So the 60 carbon structure is known as the Buckminster fullerene structure. And if you want to know about the benzene structure, we have to, let me tell you, let me show you. 1 second. Wait a minute. Let's see. See, do you think this is benzene? Do you know about the benzene?
Yes, sir.
This is benzene, right?
Yes, sir.
No,
Sir,
actually, it's not benzene. Benzene having 3 triple bonds
with
in
each other.
adjacent carbon, right?
Yes,
This
sir.
is the benzene, right? This is not the benzene. This is not the benzene. This is the benzene. Just because benzene having double bond on the adjacent carbon, as we can draw here, like carbon is carbon, right? This is a hexagonal structure, but if we draw the double bond between these adjacent carbons, then we will get the benzene structure, right? The formula for benzene is C6H5. It's an aromatic compound.
Sir,
What is that?
it is C6H6, sir.
Oh, sorry. It's C6H6, sorry. C6H6, and it's an aromatic compound, right? What are aromatic compounds? They produce specific type of smell, right? Specific type of smell, and different aromatic compounds having different properties and different smells as well. So if we want to identify that specific compound, if the compound is aromatic, then we can easily identify that compound also, right? Benzene having a specific pungent smell, like not like exact not pungent, but it's a fruity smell as well. I hope you understand that specific concept,
Yes, sir.
right? So if we talk about the benzene, it's an unsaturated compound. It's an unsaturated compound. If this compound is saturated, then this will become any hydrocarbon having 6 carbon atoms, or we can call it a hexagonal structure. See? Or we can name it as hexane. Why hexane? Just because ane represents single bonds, right? Is your doubt clear?
Yes, sir.
Right. Any more doubts to anyone?
Sir,
Yeah.
I'm audible.
Rahul
Sir,
Kashyap.
Rahul Kashyap. Yes,
Right,
sir.
right.
Sir, could you tell me, sir, could you tell me why we write ethanoic acid as CH3COOH and call it as acetic acid? And why don't we call it as C2H4O2? I've written chat box.
Wait. Let me write that specific thing. Okay. Then you can ask me after that. Okay. You're asking me like CH3COOH is ethanoic acid, right?
Yes, sir.
And the next one?
We call it as
Acetic
acetic acid. And
Okay.
sir, why don't we call it as C2H4O2?
C2H4O2.
Yes, sir.
Okay. So let me first of all explain you that CH3CH4 is known as the ethanoic acid just because as we know, like if we write a single carbon, named it as meth and 2 carbon chain as eth and so on. So as we can see, the structure clearly states that there are 2 carbons, right? If there are 2 carbons, we called it as eth. But in the higher classes, you will learn about that if we conclude this carbon, let me show you. If we conclude this carbon, then we will call it as ethanoic acid. But if we ignore this carbon, or if we take this as a functional group separately, then the name will be changed. Okay, as we can use the prefix and suffix, out there. So if we exclude this specific carbon from its main chain, the name will be changed. The name is concluded by Iupac, right? What is Iupac? Iupac, let me write the full form of it. International Union of Pure and Applied Chemistry, right? This organization stated that the name should be written on the function. The name should be written by specific relatable points. The relatable points are, first of all, find out the longest chain, then consider how many functional groups are there, and these functional groups is also separated by their specific activities or their properties, right? As we can see, we have COOH, we also have a CHO like aldehyde group, we have RCOR group, right? So these are separated by their specific activity or their reactivity. So if we have to write the specific name of the compound, we have to find out these specific relatable points given by the IUPAC. And then after we will write the specific name of that compound. So the ethanoic acid is also known as the acetic acid in the real world. In the real world, we can say that the common vinegar, white vinegar, we are using in our homes is the acetic acid, vinegar, right? Ethanoic acid. So if we call vinegar in different countries, no one will understand the specific word, right? But if we state it as the ethanoic acid or the acetic acid, the world will accept it just because of that specific organization known as IUPAC, International Union of Pure and Applied Chemistry, right? And for this, if we write this kind of substance, if we write this specific formula, no one will understand what it is. Actually, we have to define it in the way of formula, and the functional group will be defined it like that, like COOH. If we write C2H4, no one will understand that what is that. It's an oxide of a specific ethane group, right? As we have a general formula, CnH2n plus 2 and CnH2n, then we will have a 2 carbon here. So 2 2s are 4 plus 2 is C2H6 and C2H2, oh sorry, C2H4. So as we can see, this formula didn't explain the properties of the specific functional group. We don't have COOH group out here. If we draw the structure, we have this specific structure like 2 carbon and the specific functional group right here. It will define the specific functional group completely and clearly out here, but
Sir,
not
but is there in carboxylic acid, na sir? It is the group of carboxylic acid, na?
Yeah, it's a group of carboxylic acid, but you didn't define it here, na? You didn't define it here. It's a oxygen molecule or the oxide of that specific carbon compound. What should we call it as? Like if we draw a specific this
Sir, could you draw the structure of propanonic acid?
Where?
Propanoic acid.
Where? It's two carbon atom. It's carbon chain, right? CH3COOH. And write the specific same structure. CH3 and COOH. What is the problem with this structure? I don't understand. It's ethanoic structure. Is there any problem with the structure?
No, sir. The structure is fine, sir. He is asking about another structure.
Okay.
Sir,
For the another structure,
propanoic acid.
for the another structure, you can just add a specific carbon again. Sorry. See, there is a 3 carbon chain, right? Numbered as 1, 2, and
Sir.
3.
Sir, whether we call it as CH3C2H COOH or C3H6O2.
We should call it as C2H5 C2H5COOH. We have to call it as C2H5COOH. We have to write it like this only. If we write it like this will be completely wrong. We have to specify that specific functional group is there in that specific formula, right? We have to show that. If we didn't show that, it doesn't mean anything. It didn't mean anything. If I wrote like C2 C2H5 OH, what we will call it as? What is this? What is this? Can you please tell me what is this? C2H5OH, what is this? I will explain it in the video, right? There's 2 carbon chain and we have a specific functional group OH, right? It's ethanol.
Sir, ethanoic acid. Ethanol.
It's ethanol, right?
Yes, sir.
But
OH group.
what if I write it as like this?
Sir, then it will become ethanoic acid.
See, if there is 2 carbon and there is also 2 carbon, and if we wrote the specific functional group out there, then we can clearly define that this is carboxylic group and this is aldehyde group, right?
Yes, sir.
But if we add this carbon to this specific compound, then we will get confused. C3, H6, O2, right? And C3, H6, O. See? Can you explain me these 2 structures? What is this? It
No,
doesn't
sir.
mean anything. Nothing. But if we show the specific functional group with that specific compound, then we can classify them easily, right? So it's a basic what we can say it, it's like a basic thing to write that specific formulas, right? If we wrote this will be completely wrong, but if we wrote like that, this will completely all right. Okay, in the higher classes you will learn these how to write these specific structure with their specific functional group and formulas. Don't worry about that. You will guaranteed understand that specific points that are given in the NCERT. You will guarantee completely you will understand about it. Don't worry about it. Is there anything more? Anything?
सर अल्केन्स का सर मीथेन का स्ट्रक्चर एक बार बनाएगा अल्केन्स ग्रुप का.
अल्केन में मीथेन का ग्रुप, मीथेन का
Yes, sir.
स्ट्रक्चर.
Yes, sir.
The formula is CH4, right, for the methane.
Yes, sir.
Carbon, specific hydrogens. And if you want the Lewis dot structure, then we can also draw it like that.
सर वो तो बनेगा ही नहीं ना सर. मीथेन अल्केन्स का जो मीथेन ग्रुप है n equals to 1 सर, इट विल उसका वैलेंस इलेक्ट्रॉन ड्यूप्लेट पूरा करेगा ना सर.
हाँ, डेफिनेटली CH4 करेगा ना वो उसमें से. अगर उसको अल्काइल ग्रुप में कन्वर्ट होना है, if we want to convert it into the alkyl group, then we can remove that specific hydrogen from there. The hydrogen will be removed and the compound will become the alkyl group. This is the alkane group and this will become the alkyl group if we remove that specific hydrogen from it. Right? We just need to remove one hydrogen to make this specific electron free to bond with another compound, any other compound like X or whatever it is. It may be the functional group or it may be a hetero group like chlorine, fluorine, bromine, iodine, etc. Is it clear?
Yes, sir.
Read the.
Sir,
Okay. What?
sir, could you tell me the formula for methanoic acid?
For the methanoic acid, right? It's
Yes,
also
sir.
known as the HCOOH. It's a formic acid also. We also known as it's a formic acid. That's a methanoic acid. We will conclude it as a
Thank you,
single
sir.
carbon. First of all, let me tell you that if we conclude this carbon, then we will explain it as meth structure. But if we exclude this specific carbon, then we will add CH3 here as well for the meth structure. This is really confusing for all the students that if we add CH3, we will call it as a methane. But if we add the specific COH group or the carboxylic group, it will become the eth structure, right? This is the biggest confusing characters out there. But in the naming of the Iupac naming, if we exclude this specific carbon, so we will call it as a meth structure. And if we include this specific carbon, then we will call it as a eth structure. Clear?
Understood, sir.
It's a kind of typical thing. Organic chemistry is quite simple, but little bit confusing. So don't get confused all the time. If you have any kind of doubt, you can ask me freely in the comment section or whatever it is. We will definitely reply you back on the live sessions also. Right?
Sir, the molecular formula of homologous of butane, sir.
Actually, homologous series is kind of different thing. Like if we add CH2 in any other compound, it will make a homologous series. Right? Homologous series.
I am asking about, sir. I know, sir, but sir, my question is that the molecular formula of homologous of butane, sir. I'm just asking the formula, sir. I'm getting confused in that.
Okay, you can use the specific formula for CnH2n plus 2 for N structures like alkane. If you write butane, so butane stands for the 4 carbon, right? C4 H2n into 4 plus 2 C4 H10. And if we want to draw the structure, then we can draw it like that.
Sir,
Yeah.
sir, there is one question. Write the formula of the second member of carbon compound having functional group bond OH.
Can you speak again?
Sir, the question is write the formula of the second member of the carbon compound having
Okay.
functional group bond OH.
Okay. You want me to draw a specific compound having OH group in it, right?
Yes, sir. Yes, sir.
Okay, I will draw it like that. Wait a minute. So any kind of formula you have to write, any kind of formula, just use the specific CnH2n formula for the basic groups for alkanes, CnH2n for alkenes, and CnH2n minus 2 for alkynes, right? First of all, you have to understand these formulas. Then after you can draw any kind of formulas that regarding with any kind of functional groups or the hetero groups that is belong to. So if we have to draw the specific formula, if we have to draw the specific structure for containing OH group, then we can add specific numbers of carbon and it will change its name to according to its naming, like meth. Right. So if I add any of these formulas like C2H5, alkyne, alkanes, it's alkanes. It's alkane. Now remove the specific H ion. It will become the alkyne group. And if the alkyne group is joined with a specific OH group, then it will known as the ethanol. Any more doubt?
Sir, could you explain homologous series?
सर
Okay.
फर्स्ट इससे जो पहले वाले सर जो स्लाइड में था जो ब्यूटेन के बारे में होमोलोगस के सीरीज में पूछे थे बट सर इट इज देयर C3H8 सर
It's C3H8.
Okay. Not 10.
Okay. Actually, it's for the alkyne groups. Alkyl groups. Like if I draw like CH3, now I'm going to add CH2 in it, right? So what we will get? We get C2H5. If I also add CH2, then what we will get? C3H7, right? But in the case of CH4, we will get then again add CH2, we get C3H8 here. Right? It's a propane.
नहीं आया सर समझ
If we add CH2 in that specific alkyl group, then we will get the specific alkyl group with the homologous structure like C2H5, C3H7. But if we add the alkane group, if we add CH2 in the alkane group, then we will get the specific alkane with specific CH2 difference, like differentiation of specific CH2.
ओके सर ये सर आ गया सर
है ना? जैसे ये CH3 है, आप में इनको क्या बोलेंगे? मिथाइल, और
यस
ये हो
सर
जाएगा मीथेन, है ना? तो यहाँ पे अगर मैं बोलूंगा ना, नाम लूंगा, तो ये हो जाएगा आपका इथाइल एल्कोहल. अब एल्कोहल क्यों बोला? जस्ट बिकॉज ऑफ दिस फंक्शनल ग्रुप, राइट? एंड इथाइल क्यों बोला? क्योंकि यहाँ पे C2H6 की जगह पे C2H5 और एक H आयन हमने यहाँ से निकाल दिया, अल्केन को हमने अल्काइल बना दिया, कन्वर्ट कर दिया किसमें? अल्काइल. गॉट इट? So
यस सर
homologous series is just nothing the difference of CH2 or any kind of specific, difference of specific C2H6, like C2H6 with the CH4, what we will get? So, it's actually just, let me clear it out. If C2H6 is there, and if we add CH2 in it, we will get C3H8, and in the C4H10, as stated in the NCERT, C4H10, if we add CH2 in it, we will get what? C5H12, right? Let understand it as in the formula, like CnH2n plus 2. So what we will get, if we have a 5 carbon here, then we will put n is equals to 5, C5, H 2 into 5 plus 2. What we will get? C5H12. Okay. If we get a specific compound of alkane, alkene or alkyne differ with specific unit, then it is also known as the homologous series. Am I clear? Aniket Kumar.
Yes, sir. Sir,
Yeah.
what are difference between alpha rays and gamma rays?
Alpha rays and gamma rays. Okay. It's a different question from. Okay, let me show you. Do you know about the spectrum? Do you know about the spectrum?
Yes, sir. So
Okay.
that comes person in night.
Yeah, spectrum. Actually, the spectrum is nothing, it's a radiation, right? And they have different wavelengths. They have different wavelengths. If we talk about the alpha rays and the gamma rays, they differ in the wavelength. They differ in the wavelengths, right? Alpha ray is having a different wavelength and the gamma ray is having a different wavelength. I don't remember the specific number of these wavelengths, but I can clearly told you that alpha ray is having the different wavelengths, the gamma rays also have a different wavelength. We have a visible region. We have a visible region in which we will get the specific color Vibgyor.
Sir,
Yeah.
so I wanted the explanation in chemistry. So how they become alpha particle and gamma particles.
Okay. Actually, the alpha particles and the gamma particles are different in specific sizes. If we talk about specific sizes, see, the particles are in the different sizes and as well as in the different wavelength. I will clear it completely. Like if the let's assume the wavelength of alpha particle is this and the wavelength of gamma particle is this. First of all, let me finish it. You will guaranteed understand it. If the wavelength of alpha particle is this and the wavelength of gamma particle is this, there is a huge difference in these wavelengths, right? So the alpha particles, what are particles? Actually, it's nothing, it's a light particles, and we can completely define it as energy packed specific amount. See, if the particle, we can clearly explain it as the alpha particles are the energy packed compounds, or we will call it as a quanta. In the quantum physics, it will clearly explain that the particles are made up of specific energy, and the energy having the different wavelength. That is why they are different, right? Alpha particles and gamma particles are differ in their specific sizes and the energies they pursue. Like the quanta or the unit that define that specific particle, if the units are different or the energy levels are different, then the particles are also different and they have the specific different intensities as well. If the intensities are different, then we can clearly state it as like in the visible section. In the visible section, the particles shows different energy modules, and in different sections in the spectrum, they shows different energy modules. So if you want to understand a specific concept, you have to understand what is quanta and what are the particles. First of all, you have to learn about these things, right? Do you know the person named Planck who gave the quantum theory? Do you know about him? Anything? Planck's?
No, sir.
No, you have to learn about it. Like they stated a specific particle as a bundle of energy or packets, small packets of energy. The particles are nothing, it's the packets of energy. In light, if we talk about the light contains small packets or bundle of energy, and they stated as the particles. So the alpha particle is nothing, it's just a bundle of packet of energies. So if the energy configuration is different, then the particle is also different. So the alpha rays and the gamma rays having the alpha particles and gamma rays having the gamma particles. And these particles are differ from their specific wavelengths. So wavelength, if the wavelength is different, then the frequency is also different. Frequency is also different. Do you understand it? Or I have to explain more about it?
Sir, I understand.
Okay. Let me clear it out once again. Wait a minute. I will assure you that you will specifically learn that specific concept. Right. As we can see, it's a light source. We will get the light rays like this. Okay. In each light ray, there are thousands or millions of particles in specific ray, right? Millions of particles in a specific ray of light. These particles are nothing. They are stored energy packets. As explained by scientist Planck, they stated that the ray of light consists packets or bundles in the form of energy. So these packets and bundles travel in the specific direction, travels in a specific direction with specific wavelength, let me write it, specific direction, and in the specific with the specific wavelength.
I'm sorry to interrupt you, sir. Actually, that meeting is about to end only. So, students, these sessions, that live sessions, actually we are conducting every Sunday, same time, 6 p.m. actually. So, inform your friends also. Those who need the class, actually, they are from the 8th, 9th, 10th. So they can clear their doubts. Whatever the doubts they're having from the particular subject, they can discuss in that classes there. Okay. So just inform everyone there. Okay, we are having a session, live session every Sunday that is free of cost. No need to pay anything in that. So please tell them to join on time there. Okay, and ask their doubts. Okay. So okay, Sandy Rathod sir, thank you for this one. And yeah, any
Thank you, all of you.
Yeah, I want to add something here. So to all the students, yeah, so we are conducting this live class every week on Sunday at the same time, so that you can solve your doubts. Students, see, we want to help you excel in your academics. So please do join, solve your doubts. I mean, not only you should join, but you should ask your friends also, tell your friends also to join, and share our YouTube link, Facebook page, Instagram page link with your friends. So from next time onwards, we will go live everywhere. So you can not only you should join, but you can ask your friends as well to join. So yeah, that's all from my side. And you can even sign up on SchoolQuizz site, and you can receive the link from there as well to join this, and you can even solve quizzes. And yeah, you can ask doubts through these sessions, so we want to help you. So yeah, whatever doubts you have, you can get it solved here. So yeah, that's all I wanted to add.
Students, please to sign up at schoolquiz.com and take quizzes, excel your knowledge. And also as we are keeping every Sunday, we are keeping a live session. So please join and tell your friends as well to join so that you can clear your doubts regarding the subject in your academics. Yeah. Thank you.
Yeah, thank you.
yes, sir,